So welcome to another exercise from the Year 13 textbook. This is exercise 2B again. It's 2B.2. So basically I'm just doing a few more examples of domain range. Because when we did this in class with my last group, essentially they took a long time to get through it. So that's why we split it into two. But essentially it's the same stuff and a few more examples, then finish the exercise and then do the homework. So if that all makes sense, let's have a go at this. So a little reminder what domain and range actually are. They're meant to be, of course. The domain is the numbers that we're able to put into a function in the x direction effectively. So in this graph, I'm just looking at this graph now, and my assumption is that that is 1 and that is 2, 3, 4, 5. Oh yes, it actually is a 5 there as well. I just noticed it never goes, there's no numbers on that side. All the numbers are on this side. So immediately I'm thinking to myself, the largest possible domain of this is effectively all the numbers bigger than 2. If this is a log graph, and it probably is, it is probably going to be the domain is x is such that x belongs to the real numbers and x is greater than 2. And I don't know because I haven't done what the actual function was. Unlike this, by the way, the range, you'll notice the range goes all the way down to the bottom. There's no indication that it stops somewhere. And I reckon if I did that, it'd carry on going up and up and up. And it's going up slower, but my gut feeling is that will carry on going up and up and up. And so the range for this would be y belongs to the real numbers, and that's it actually. There's no restriction on it at all. It's just all possible numbers. So I see what I wrote. Yes, that's what I've written. So the domain is x is such that x belongs to the real numbers and x is bigger than 2, and the range is all real numbers. So this is what we're looking for then. Domain is the set of all possible inputs or x values. The range is the set of all possible outputs or y values. I find the graph the most useful thing. So immediately, interesting, I said it's the most useful thing, and then immediately on this question it says sketch the function. So sketch the function y equals f of x for this. Well, just remember our transformations. We should know that this is a square root graph. And if I do a +3, that is a translation. That's like in the bracket. So my actual graph should look like that, hitting -3 on the x-axis. So what's the largest possible domain? Well, in my mind, I'm thinking the domain is, well, you can see it stops there. So it's all the numbers bigger than that. X belongs to the real numbers. X is greater, and I think it can be equal to -3 this time. My feeling is that the range, well, it doesn't go below the x-axis. So it's like ones we've seen before. Y belongs to the real numbers. You'll get bored of that, but you don't want to lose a mark for not writing it. Y is bigger than or equal. Now this, of course, what you need to remember is this is the 0 line here. So bigger than or equal to 0. Let's see what I've got. There's the graph. Does hit at -3 as I said it would. And there's the answers. Domain x is greater than or equal to -3. Range is y is greater than or equal to 0. So we're all happy with that. Different function this time. This time it's actually a straight line graph. This is the straight line graph of y equals 4x -3. Now the only difference on this though is it's got a restricted domain. So in the question they've said, hang on a bit, for some strange reason we're only going to let x be between -1 and 3. So if I was to draw this graph, not my best, there is my graph. It's crossing at -3. I know it's straight because it just says, it's like the y equals mx plus c scenario that you learned at GCSE. So many x plus a number. So that means that the c value, the y-intercept is -3, and it's got a gradient of 4. That's what the graph looks like. But, this is the but, it goes from -1. So really, it doesn't go beyond there. That's -1. This bit doesn't exist. So it starts there. And I'm going to say it goes up to 3, which by pure fluke, or maybe I've pretended, it goes up to there. Okay, so there's my graph, and it's important to realize that there is a start and an end to this, unlike the normal y equals 4x minus 3, which goes up and down forever. Carry on forever and ever and ever. But this one doesn't. This stops at where x is 3. It stops where x is minus 1. In actual fact, it doesn't actually quite get there. It's more than minus 1. It's less than 3. Anyway, what's it mean for the range? Well, all I need to know now is what value does that give me? What value does that give me? So if I calculate these things, when f of 3 gets put in, 3 goes in, I get 4 3s are 12, minus a 3 is 9. And f of minus 1, exactly the same idea. I do 4 lots of minus 1, which is minus 4. Minus 3 is minus 7. So the range, and I'm going to write f of x because they have in the question, is between minus 7 and positive 9. Now remember what you're meant to write with this. You're meant to write range. We're going to say f of x belongs to the real numbers, comma, and then this is true as well. So that's what I did. There's my straight line graph. There it is. I know in this one I wrote y, but I commented last time, it doesn't really matter. Y belongs to the real numbers, and y belongs from minus 7 to 9. Here's my next one. I'm not even sure that this is the right... No, yeah, something's gone wrong here. So this here is not this function. I'm just going to see what I think it is. Oh, right. Yeah, I know what it is now. It's meant to say 1 over x minus 2 minus 7. So for some reason that fraction at the start of it got mixed out. Now, I suppose what you need to know in order, I mean, this is the graph, we know that's the graph, so that what you need to know to get to that stage is you need to know the standard graph, which is 1 over x. You can see that it looks like a 1 over x graph. And the standard graph for that is one of these. We did some of those before. And there's obviously the axes drawn. Now, you'll notice there are two transformations applied. There's a minus 2, that's effectively like in a bracket. And there's a minus 7 at the end. So both of those are actually translations. The minus 2 will move it 2 to the right. So that effectively, normally you draw an asymptote there. That's a minus 2. Oh no, actually, I just realised that's meant to be a plus 2. Because then it goes to the left. That's right. So that plus 2 in brackets is what the function's meant to be. And with that plus 2, it will move it to the left. And there you go, I've moved it left. And it would look broadly the same, just shoved over to like that. But then it's also got the minus 7 on the end. So what the minus 7 does is it moves it down. And you remember in the bracket it does the wrong thing. That's why the plus 2 moves it left. And the minus 7 does actually move it down 7. So again, the best way of thinking of this is draw the asymptotes at minus 2. And we need an asymptote at minus 7. Everything else stays the same. So the shape of the graph now looks like this. Getting closer, but never touching those asymptotes. And it looks like this. So that does look like that, and the only thing that's missing off this is the asymptote here and the asymptote here. But now you can see that you go, oh yeah, maybe. So anyway, what's the largest possible domain and range? So I'd go here, the domain, the largest possible domain is x belongs to the real numbers, and the only number I'm not allowed is this minus 2, because if I put minus 2 into that, I get 0 on the bottom of my fraction, and I can't divide by 0. That's essentially it, but you can see it there as well. And so x is not equal to minus 2, and the range, well, it's exactly the same, y, or f of x. I'm going to write y since that's what I did last time. Y belongs to the real numbers, y is not equal to, what was it, minus 7. There's the domain, that's worked, and there's the range. So now I've got the right function. Just remind you that here the right function according to me was 1 over x plus 2 minus the 7. And your job, and I told you it was relatively straightforward, this one, because we've done most of it already. Your job is to finish off exercise 2B. Now, you may well have done some of these already. If you haven't, or if you haven't done any of them yet, your job now is to do all the questions that you can possibly do. Maybe cherry pick a few if you think they're too easy. Maybe miss out a few at the end if you think they're too hard. But see what you can do. Best of luck. Bye.